Hello and welcome back to Math Concepts. In this video we are going to continue our discussion of conditional probability. As we discussed previously, conditional probability has the effect of changing the sample space. And here we are going to look at situations where we have a multi-part experiment and the outcome on the first part affects what is possible on the second part. Okay, so let's switch over to the document camera and get into some examples of using conditional probability. Alright, so the key idea is I want you to be able to apply conditional probability to problems dealing with cards. So let's look at this first example. Let's imagine two cards are going to be drawn from a standard deck without replacement. Okay, so that means we take one card out, we keep it, and then we draw a second card. So we want to find the probability that both cards are hearts. Alright, so let's look at our sample space. Okay, we're going to use the counting principles to find the size of the sample space. Okay, we have a two-stage experiment. We draw the first card, we draw the second card. First card, we have 52 possibilities. Second card, we've only got 51 possibilities. Okay, so that is going to be our sample space right there, 52 times 51. The reason we have a 51 here is because, of course, we've taken a card out of the deck. Started out with 52, you take one out, you got 51 left to choose from. Okay, so let's think about how many hearts are in the deck. You want to choose one heart for the first stage. Okay, well, there are 13 hearts in the deck. There's 13 of any suit, right? You got 4 suits. Take 52, divide by 4, you get 13. 13 cards per suit. So in your first draw, when you're talking about drawing a heart, you have 13 possibilities. Your second draw, given that the first one is a heart, you have 12 possibilities. So the probability of drawing 2 hearts here is 13 out of 52 times 12 out of 52. Okay, so I want you, 12 out of 51, right? The sample space changed here. Okay, so this is the probability of drawing a second heart given that the first was a heart. Okay, so even though this problem didn't say that keyword given, it's kind of in there, right? Because when you draw that second card, you're dealing with a new sample space, right? You've only got 51 cards left in the deck. Let's look at another one. Okay, and in this one we'll say we draw 3 cards without replacement. We want to find the probability that the first 2 cards chosen are diamonds and that the third card is black. Okay, so we're going to be multiplying here. So probability of diamond, diamond, and then black card. Okay, well, the probability of a diamond on the first draw is 13 out of 52. The probability of another diamond, given that this first one was a diamond, well, you got 12 diamonds left out of 51 cards. Now let's look at the probability that we draw a black card. Now we only have 50 cards left, and here we're looking at the probability of drawing a diamond on that first card, another diamond, and now we're switching to black cards. Okay, well, of course we know that diamonds are both red, so in this first draw you took out a red, you took out a red, So all the black cards are still there. There were 26 of them. Half of the original deck is black. Okay, so we would multiply these fractions, and that is our probability. Let me crunch the numbers right quick. So I would do 13 out of 52 times 12 over 52 times 26, 12 over 51 times 26 over 50. Okay, so this is approximately 0.031 and that is to the nearest thousandth. Okay. And just one quick note here. So we say events are independent if one event happening has no effect on the probability of the next event. Okay, so up here, these are not independent events. What happens on the first draw affects what is even possible on the second draw. Okay, right? If you do your first draw, no matter what you do, you've taken a card out of the deck. So you've only got 51 left. Okay, so these are not independent. Independent events would be like tossing a coin multiple times. Whatever happens on the first toss, well, you still have your heads and tail possibilities for the next toss. Okay, so that would be a situation where you had independent events. Drawing cards with replacement would be an example of independent events. If you draw a card, look at it, write down what you got, put it back in the deck, shuffle it up again, then you could still have any of the 52 cards on the next draw. Okay, so those would be examples of independent events.